Procedures. In this video, we will define and demonstrate how to create procedures. A procedure is a set of code that is referred to by name and can be called or invoked at any point in the program simply by writing the procedure's name. But before we get into how to create a procedure, let's first explore why they're necessary in the first place. Consider the following code segment. In the first line, we ask the user to enter a temperature in Celsius using the display command. We then retrieve the input from the user using the input command and store it in a variable named Celsius. We then apply the conversion formula for converting Celsius to Fahrenheit. We apply it and store it in a variable called Fahrenheit. Now consider this code segment. Here we're doing the exact same thing, but instead of typing out the formula for converting Celsius to Fahrenheit, instead we use a procedure named to Fahrenheit that does the conversion for us. If you were assigned to write a program just like this, which approach would you prefer to use? The approach used in code segment 1 or the approach used in code segment 2? More than likely, you'd want to use the approach used in code segment 2 because 1, it's easier to remember. As a human, it's much easier to remember a name rather than numbers, and it's easier to read. One thing programmers have to do a lot of is read over old code either previously written by themselves or written by somebody else. And as a human, it's much easier to read names than it is to read numbers. Now consider this code segment 3. Here we have a list of numbers which we'll assume are grades, and we're going to assign that list to a variable named Jill because these are Jill's grades. Then we're going to use a for each loop to increase each value in the list by 5, or in other words, we're curving each grade by 5 points. We then do the same for Jack's grades, and then we do it again for Tim's grades. This is one way to approach the situation of curving the scores for 3 separate students. Now consider code segment 4, where we do this exact same thing, but instead of using a for each loop, we simply call upon a procedure named curve, which does the curving for us. We then do the same for Jack's grades, and then the same for Tim's grades. If you were tasked with curving the scores for several students, which approach would you rather use? The approach used in code segment 3 or the approach used in code segment 4? More than likely, you'd rather use the approach used in code segment 4. Not only is it easier to remember and easier to read, but it's also more concise. As you can see from these 2 code segments, by switching from using a for each loop to just a procedure, we saved ourselves a lot of space. Code segment 3 required 12 lines of code, but code segment 4 required only 6 lines. So we saved 6 lines of code. Had we been curving the scores for 10 students, we would have saved 20 lines of code. And had we been curving the scores for 25 students, we would have saved 50 lines of code. In general, anytime you are using a sequence of steps repeatedly in your program, turning those steps into a procedure will save your program space. In summary, procedures reduce complexity in our programs by making them 1. Easier to read, 2. Easier to remember, and 3. More concise. That all being said, now that we've discussed why we use procedures in our program, let's now discuss how to create them. In case you're not aware, the to Fahrenheit procedure is not a procedure that's already provided to us by the College Board, the way the input command is provided to us or the display command is provided to us. No, to Fahrenheit doesn't exist. The only way it can exist is if we create it. So how do we create it? By first typing the word procedure. This is how we indicate that we're getting ready to create a procedure. We then type the name we want to give that procedure, which in this case is to Fahrenheit. Then inside of a pair of parentheses, we type the parameters for that procedure. What is a parameter? Parameters are inputs given to a procedure. A procedure can receive 1 parameter, 2 parameters, 3 parameters, any number of parameters. But in the case of to Fahrenheit, we only need 1 parameter, a number, the Celsius temperature that we want to convert to Fahrenheit. Then, inside a pair of curly brackets, we're going to define what we want done to the parameters. The first thing we want to do is apply the formula to convert that temperature from Celsius to Fahrenheit. We're going to store that value in a variable called f. Then we're going to return that value from the procedure. Now, what does the return keyword do? Return sends the output of the procedure back to the program. This return keyword is what allows us to take that value in f and assign it to the Fahrenheit variable here in our main program. And now the curve procedure. How would we create the curve procedure? Once again, we first type the word procedure to indicate that we're getting ready to create a procedure. Then we type the name we want that procedure to have, which in this case is curve. Then we type the parameters. Here, curve only needs one parameter. It's going to be a list of numbers, and we're going to name it grades because that's what the numbers represent. They represent grades. Then inside the body of the procedure, we're going to use a for each loop to curve each grade in that list by 5. Or in other words, increase each grade in that list by 5. Here, the return keyword is not necessary because we're changing the list inside the method. Hence, there is no need to output anything back to the main program. Here's another way we could have defined this curve method. Here, instead of a for each loop, we use a repeat loop. Recall that a repeat loop is what we use when we want to execute an instruction a fixed number of times. So how could we use a repeat loop for this method? Well, we first start by declaring a variable named I and initializing it to 1. This variable is going to be used as our index into the list. Then we're going to start a repeat loop that's going to execute a number of times equal to the length of the list. So if the length of the list is 5, then the repeat loop will loop 5 times. If the length of the list is 10, then the repeat loop will loop 10 times, so on and so forth. Then inside the for loop, we use the I variable as our index to increase the value at index I by 5, or in other words, curve it by 5. After we do that, we increase I by 1. Hence, when we first enter the repeat loop, we start by increasing the value at index 1 by 5. Then in the second loop, we increase the value at index 2 by 5. Then in the third loop, we increase the value at index 3 by 5, so on and so forth until the repeat loop is finished. We'll close this video by looking at one more procedure example where this procedure receives more than one input. It receives 2 parameters. It's called sum, and its purpose is to compute the sum of the 2 parameters. And it does that by simply returning a plus b. With this defined, we can now invoke the sum method in our main program. When we invoke the sum method with 1 and 2 as the parameters, we get 3 as our output. When we invoke it with 5 and 10 as the parameters, we get 15 as the output. And when we invoke it with 25 and 25 as the parameters, we get 50 as our output, so on and so forth.